What if everything around you had a mirror version? A mirror version that looks the same but behaves in the exact opposite way. From the air you breathe, to the phone in your hand, to your own body. Everything is made of matter. But science tells us that there exists another strange form of material in the universe called antimatter. Antimatter is one of the most fascinating and mysterious ideas in modern physics. It sounds like science fiction, yet it is very real, scientifically proven, and extremely powerful. In this video, we will explore: first, what matter and antimatter are; second, their historical discovery; and finally, a simple explanation of how matter and antimatter work and why they matter so much to our universe. The story of antimatter begins in the early 20th century. In 1928, a British physicist named Paul Dirac was working on equations that combined quantum mechanics and Einstein's theory of relativity. While solving these equations, Dirac found something strange. His math suggested that for every particle of matter, there should exist another particle with the same mass, but opposite electric charge. At first, this idea seemed impossible. Scientists believed nature only favored matter. But in 1932, American physicist Carl Anderson made a groundbreaking discovery. While studying cosmic rays, he observed a particle that behaved like an electron, but with a positive charge. This particle was named the positron, the antimatter counterpart of the electron. This discovery confirmed Dirac's prediction and proved that antimatter actually exists. Later, scientists discovered antimatter versions of other particles, such as antiprotons and antineutrons, mainly through experiments in particle accelerators. To understand antimatter, we must first understand matter. Matter is anything that has mass and occupies space. Everything we see around us, stars, planets, water, rocks, plants, and people, is made of matter. At the smallest level, matter is made up of atoms. Atoms contain particles like electrons, protons, and neutrons. These particles have specific properties such as electric charge, mass, and spin. Together, they form the building blocks of the physical universe. Antimatter is very similar to matter, but with one crucial difference. For every particle of matter, antimatter has a corresponding antiparticle with opposite properties. For example, an electron has a negative charge. A positron, its antimatter partner, has a positive charge. Similarly, a proton has a positive charge, an antiproton has a negative charge. Apart from the charge, most other properties remain the same. This means antimatter is not evil matter or imaginary material. It follows the same physical laws as matter. Here is where things become dramatic. When matter and antimatter meet, they annihilate each other. Annihilation means both particles disappear. Their entire mass is converted into energy. This energy is released in the form of gamma rays, following Einstein's famous equation, E equals mc squared. Even a tiny amount of antimatter can release an enormous amount of energy. This is why antimatter is considered one of the most powerful energy sources known, though it is extremely difficult to produce and store. One of the biggest mysteries in physics is this: if matter and antimatter were created equally during the Big Bang, then why is the universe made mostly of matter today? Scientists believe that shortly after the Big Bang, a small imbalance occurred. Matter slightly outnumbered antimatter. As matter and antimatter annihilated each other, this tiny excess of matter survived and eventually formed stars, galaxies, and life. The exact reason for this imbalance is still unknown and remains an active area of research. Although antimatter sounds dangerous, it has practical uses. In medicine, antimatter is used in PET scans, which help doctors detect cancer and study brain activity. In research, antimatter helps scientists understand fundamental laws of the universe. While antimatter-based energy or propulsion remains theoretical, it continues to inspire future technologies and space exploration ideas. Matter and antimatter reveal how strange and beautiful our universe truly is. From a mathematical prediction to experimental discovery, antimatter has transformed our understanding of physics. It reminds us that reality is often more surprising than imagination, and that many cosmic mysteries are still waiting to be solved.
Like, share, and subscribe my YouTube channel. Yeah.